Measuring rates. Before we go into this, there are some terms that you need to know. The first one is ratio. A lot of people think of ratio as a fraction because a fraction is a ratio. But a ratio is a non-negative numbers, so only positive, and they're both not zero. Ratios are written one of three different ways. The A and the B here represents the numbers themselves that are not zero and are non-negative. Where you can have A colon B. You can write A and the word 2 in between B, or as a fraction A over B. Now, if you have a ratio that is in a word problem, the order of the numbers, the number A is the first one that's given to you, and B is the second one. So when you're setting up your ratios, a lot of people are like, well, how do you set it up? If you drove 110 miles in 2 hours, you would write 110 over 2, and that would be, that's one way of doing it. It's not the only, but that's what that means by order of numbers. Now, two ratios. This part right here is a little confusing. This part right here. The two ratios A and B and C and D. And so in other words, two completely different ratios are equivalent or equal to each other if there's a positive number, C, meaning any number, such that C is equal to your A value times that number C, and D is equal to the B number times that number C. I know that's very confusing, but let me give you a quick example. If I have 1/2, and let's say this is my A and this is my B, and I want to know, is it equal to 2/4? This is my C and this is my D. Hopefully you can look at that and say, yeah, those two things are equivalent. 1/2 and 2/4 are the same thing. What I did is I took the original A and B value and I multiplied them by 2. That would be that little c. So in other words, if I took my A value times this C, it would give me this here. And then the B value times that same C, it gives you that value there. That's what this means. B times that little c, A times that little c. That's what that means. Hopefully that's a little clearer. We'll go over that a little bit later too to make a little more sense of it. A rate is ratio two quantities with different units. It usually, in real world situation, a rate refers to time somehow. You know, how long it, hey, look, I said trakes. That is not ticket worthy because I found that myself. How long it takes to do something. For example, 5 miles in 2 hours, or how long it took you to make a certain number of things. It usually refers to time, though, when you talk about rate. A unit rate, the second number, the B value, is equal to 1. Hey, the bell rang. Gotta stay here, though. Example, if you traveled that same one that I had, the 5 miles in 2 hours, well then, what you want to know is how far did you travel in 1 hour. You want to get that B value equal to 1. And it would be 2.5 miles in 1 hour, or 2.5 miles per hour. Okay? Now let's move on to some examples. Here I have some ratios. Boys to girls. Hey, what happened to my chart here? There. All right, ratios of boys to girls. Let's say I have a class, and my first class I have 10 boys, and my second class I have 11 girls. The ratio of boys to girls. So here it's telling you boys to girls. So what comes first? What comes second? You would write it as 10:11, or you could write it as 10 over 11, or 10 to 11. For class 2, let's say I had 15, and I had 15. Then my ratio is 15:15. Pretty easy, right? Now let's say it was a whole 7th grade. I had 110 boys in 7th grade, and I had 130 girls in 7th grade. Go ahead and write that ratio. You should have written 110 to 130. Okay, so equivalent. Let me see if I can come up with equivalent ratios. And hopefully this will make a little more sense. So if I have the first one, the 10 to 11, if I wrote it as a fraction, and I wanted to come up with an equivalent ratio, I just multiply the top and the bottom number by the same amount. You pick any number you want. I'm going to use 2. 2 over 2. 10 times 2 is 20. 11 times 2 is 22. So this is an equivalent ratio. Now the next one, 15 over 15. You could multiply the top and bottom by the same amount, but you could also divide. If you look, you're like, oh, hey, they both can be divided by 15 and 1 to 1. Okay, that's an equivalent ratio too. You simplified the fraction. So looking at the next one, 110 over 130, you could say, ooh, well, I could multiply that, but then you're getting into large numbers. Or hopefully you realize, well, they both end in 0. I could just take the 0 off, which is the same thing as dividing by 10. And there is an equivalent ratio. Cool, huh? All right, let's move on. I have one more sample for you today. Which one is the better by? This is a very, very common use. Again with the bell, do not leave. A very common use of unit rate or unit ratios. You go into a store and you have, there's a back to school sale and you have 30 pencils that you could buy for $7.97 or 12 pencils that you could buy for $4.77. You want to know what the better deal is. All right, well, how do you find the better deal? And the question is, you need to find out, or the answer is, you need to find out the cost per pencil. Right here, this says, which is the better buy? That is saying I need to find out the cost per pencil. And then you could really compare it. And you see that when you go to the grocery store and you want to buy pasta and you could buy it 1 pound or 2 pounds, you know, which one is really the better deal? Well, what's the price per pound of both of them? So, how do we figure that out? That is the question. Well, when we're trying to find the unit rate, remember that the second number has to be 1. And since we want the cost per pencil, in other words, 1 pencil, we want the pencils to be our second number, or our B value. So what I would do is I would take $7.97 for 30 pencils. And again, this is set up like this. And then for a unit rate, I want my B to be equal to 1. So how do I make 30 equal to 1? I divide by 30, because 30 divided by 30 would be 1. Now if I do it in the denominator, I have to do it in the numerator. And then I'm going to get approximately 27 cents. We're talking money, so I rounded it for 1 pencil. In your calculator, you actually get, on your calculator, it's 0, is it 0.265, and then it goes 6, 6, 6, and then it ends up somewhere with a 7. That digit actually isn't a 7, this right here in your calculator. What that is, your calculator ran out of digits, so it rounded it to that place, okay? A lot of students think that, but it's not. It was actually just 6 repeating. Since it's money, I went to the pennies here and rounded it. All right, the next one then, we have $4.77 for 12 pencils. Now, hopefully you realized that what I'm doing on this previous example, I took the $7.97, I divided by the denominator. You could do that. If you just took $4.77 divided by 12, you would get about 40 cents per pencil. And actually in the calculator it came out to 0.3975 in the calculator, but again, you round to this digit, this becomes 40 cents then. So which one is the better deal? Well, it's going to be the one with 30 pencils. This is the better deal, and we know it because the cost per pencil is cheaper than the other deal. That's it. Goodbye.